So we continue with the point defects, and third type is the impurity defects. Now impurity defects सिर्फ एक type of point defects नहीं है. This is a stand alone topic. इसकी अपनी बहुत importance है. आप आगे पढ़ोगे, you will get to know why is it important on its own, right? So in this first slide I have just mentioned a few important points, but I'll quickly go to slide number 2. See, I have this diagram here. It is a crystal lattice of sodium chloride. Na positive ions है and Cl negative ions. But एक जगह आप क्या देख रहे हो? There is strontium divalent positive. Now this is an impurity here. ये जो NaCl का pure crystal होता, इसमें किसी foreign atom का आना is considered as an impurity. Na plus and Cl negative की जो lattice sites है, they are the host sites. They are occupied by the host atom. And ये जो foreign atom आता है, ये replace करता है host atom को. Now ये foreign atom या तो replace करेगा lattice site से host atom को, या ये occupy करेगा कोई interstitial void. On the basis of that, there are two types of solid solutions. Going back to slide 1, defect due to the presence of a foreign atom at the lattice site in place of a host atom. तब उसको कहते हैं, उस solid को, resulting solid को substitutional solid solution. यहाँ पे Na plus replace हुआ है by strontium divalent positive से. And if the foreign atom occupies a void, it is called as an interstitial solid solution. So substitutional solid solutions and interstitial solid solutions are a result of impurity defects, right? Now ये adding impurities, again impurity का यहाँ पे literal word नहीं है. It's not a गंदगी, it is a foreign atom. That is done deliberately. We add that impurity so that we can improve the properties of these solids. What improvement is there in the properties? We'll see them. We'll see in the upcoming slides. This addition of impurity to a pure crystal is called as doping. Now doping can be done दोनों की, ionic crystals की भी and covalent crystals की भी. We can introduce an impurity in an ionic crystal. We can do it in a covalent solid. Now we have taken up an ionic solid first. It is the same slide, it's the same diagram. Impurity introduced by adding a foreign ion. If the foreign ion is in, okay, this is very important. Now see, जो आपका cation अपना इसका था crystal lattice का sodium plus, it is monovalent positive. Now impurity is divalent positive. So it is very very important एक और host site vacant हो जाए, because 2 plus के लिए 2 plus 1 replace होने चाहिए, खाली होने चाहिए. यहाँ से भी गया Na plus, यहाँ से भी गया Na plus, तब जाके यहाँ पे strontium divalent positive आएगा. Now because of this एक vacant site भी हो गई यहाँ पे, and a vacant site results in high electrical conductivity. आप आगे slides में देखोगे जैसे electrons move करते हैं एक crystal lattice में, and because of which electrical conductivity बढ़ जाती है. Holes also move in a certain direction. Because of holes भी electrical conductivity solids की बढ़ जाती है. One example is this. आप strontium chloride add करें as an impurity to NaCl. Also you can add AgCl. No, you can add cadmium chloride as an impurity to a pure crystal of AgCl. This is how you can introduce impurity in an ionic solid. Main thing is this. Introduction of impurity in covalent solids. Now before we talk about again these important points, let's go to this diagram. In this diagram, figure A में हमने pure crystal lattice लिया है silicon atoms का. Silicon belongs to group 14, carbon family का है ये, and हर silicon atom के 4 valence electrons है. This is the arrangement in its crystal lattice. फिगर बी में हमने इम्प्योरिटी इंट्रोड्यूस की है ग्रुप 15 से, एंड फिगर बी में हमने इम्प्योरिटी इंट्रोड्यूस की है ग्रुप 13 से. We'll keep coming back to this diagram. Now see, in case of the covalent solids of the elements of group 14, such as silicon or germanium, each atom has 4 valence electrons. Carbon family में होते ही ये सबके 4 valence electrons. Now impurity अगर आपने add की group 15 से, what happens? Group 15 में 5 valence electrons है. That is why ये जो arsenic यहाँ impurity आया group 15 से, there's a mobile electron also. There's an extra electron randomly moving in this crystal, right? Now this electron is negatively charged. It will start moving and improve the electrical conductivity of this crystal. Since the electrical conductivity is increased because of a negatively charged electron, that is why it is called as an N-type semiconductor, right? Okay, so let's get back to this slide. Now look at the third diagram, figure number 3. In this we have done doping again, but इसमें हमने introduce किए impurity group 13 से, and elements of this is boron. Elements of group 13 have only 3 valence electrons. So जो fourth place है, जो silicon atom की fourth place थी, that is a hole now. And hole की moment on application of electric field वैसी ही होती है जैसे एक positive. It moves like a positive ion. And that is why this type of a semiconductor is called as p-type semiconductor. Let's go back to this slide now. Now impurity is added either from group 15, elements of which have 5 valence electrons, n-type बनेगा उससे, and group 13, elements of which have only 3 valence electrons, p-type बनेगा. Thus जो आप impurity introduce करोगे, it can be both electron rich as well as electron deficient. And these defects are called as electronic defects for obvious reasons, because this is a defect because of an extra electron, this is a defect because this is impurity because of the electron deficiency. Look at the diagram again, and anything you want to learn further is given here in this slide. Now semiconductors can be, we won't say they can be of 2 types, but if it is a pure silicon or germanium crystal lattice, they are insulators at 0 Kelvin, and they become semiconductors only above 0 Kelvin. In that case, they're called as intrinsic semiconductors. Now extrinsic semiconductor is a semiconductor in which you have done doping, silicon or germanium का ही होगा, but you have introduced impurities either from group 15 or you have introduced an impurity from group 13. Because of that impurity, you enhance its conductivity, and it's called as an extrinsic semiconductor. Diode, it is basically a combination of these two, P and N type semiconductors. These diodes are used as rectifiers, as you know. Transistor क्या होता है? They are sandwich semiconductors. P and P type भी हो सकते हैं, NP N type भी, P N P type or NPN type. If you have any questions about these semiconductors, again drop in the comments.